Yeah, you better put that down before you sit down.
All right, do the gavel thing. Whoa, and I'll hold the microphone a little bit lower, not to be too loud. Welcome to the June Omaha Astronomical Society meeting. My name is John Larson. I am your president and host this evening. There will be no game shows, even though the microphone I'm holding kind of looks like I'm in a game show. If you have headphones, please use them with the meeting. And please remember to mute your microphone when you are not speaking. In Zoom, spacebar can act as a push to talk button. If you do not want to be seen, you can mute your video. And later on in the business meeting, we can unmute to file motions. Do we have any guests with us this evening? Over there? Hi.
Hi.
Tell us about yourself. How'd you hear about us?
I heard about this from them.
Oh, hello them.
I've always been interested in space, so I've been curious about it ever since I moved here about a month ago.
Oh, great. You come to the right place.
I have.
Hooray.
Hey.
Anybody else?
I'm fairly new. I'm Sammy. Been here for quite some time, but have not came in person. Person meeting, been on Zoom before. Thank you all.
All right.
Thank you. And that's your telescope right over there in the corner.
So John helped me to fix it. Cool. Thank you, John.
You're welcome. Is there anybody on Zoom who is a guest? Okay. If you decide to become a member of OAS, you will get a copy of the Astronomical League's newsletter, The Reflector. It's quarterly. Looks like a little magazine. Oh, it looks like that right over there. That's the most recent issue. We have an observing site near Weeping Water, Nebraska, which we call Astro Park. We have a telescope loan program, so you can borrow a telescope to see which ones you like, because they're different types. The monthly newsletter, the Stella, that'll get delivered to your email, as well as there are some that are on the website. And we have a Discord member, or Discord server, if you like to be on Discord. And you can vote for business meeting stuff. I know that's the most exciting thing. Upcoming dates, Zarinsky's on the 13th, but there's going to be a lot more in outreach coming up. And of course, the Mahoney Star Party is coming up on the 24th. It's one of their biggest ones. Jordan, are you on?
Hello, yes, I'm here. Give me 1 second. Let me start my video here. Hello. Yes, so I was very, very excited for tonight to bring in, welcome, and have Dr. Luis Wellbanks as our guest speaker and presenter tonight. He's a Sagan postdoctoral fellow at the University of Arizona. Had the chance to chat with him about a month ago about some of his research and his very expansive background in exoplanet atmospheres and what he's been doing and then been able to do with a lot of the new data from the James Webb Space Telescope is incredible. And some of the things that he has going on right now and then coming into the future, it's going to, I'm sure, expand our knowledge of exoplanets, their atmospheres, and just what's out there in the universe exponentially. So if we are ready to do that program, John, I'd like to welcome Dr. Wellbanks here and let him take the stand.
Thank you. It's really great to be with all of you today. Thank you for having me. Just from the 5 minutes that I've heard of everything that you do and just checking your website, your group is so fantastic. I wish there was something like that when I was growing up. Just the telescope loan program sounds so exciting. If you have questions about astronomy, real astronomy, I will be a potato. I feel like you are the real experts here when you talk about telescopes. So let me share my screen Yeah. So you're okay with me to start, Jordan? I assume the sound is okay. I'll
Yep.
just put your screen here.
I'm gonna try to bring our volume up a little bit, just a second.
You want me to turn up the volume?
I'm gonna
I mean,
turn up
again-
our volume in the room because it's a little low.
Okay, okay. I mean, I'll yell as much as I can, and then we'll go from there. I don't know if I'll make it all the way to Omaha with my voice. Yeah, I'm Luis Wellbanks. I'm in the other university in Arizona, so not at University of Arizona, but Arizona State University. I'm in the one in Tempe. And yeah, I'm a Sagan Fellow. And talking to Jordan last month, we're talking about like what to present, and she told me basically to go through a little bit of everything and leave you with kind of like what sort of exciting stuff we're going to be doing in the next year to 20 years. I did my PhD at the University of Cambridge. I'm currently in DC. There is a Gates Scholars Alumni Weekend. So yeah, if I don't make any sense, I'm a little bit jet lagged from coming all the way to DC. And I want to, as I said, just share a little bit of like, what are exoplanets? How do we find them? How we've gone from discovery of exoplanets to characterizing them. What do I mean by characterization? Some of the lessons so far and some of the ways in which I think you can help, and your help would be fantastic. And we start with the cute images, and that's one of the reasons why we like astronomy, because we get cool cartoons, and the general picture of the solar system. And this is what I was taught when I was in elementary school, right? We have our rocky planets, we have the gas giants, and we have the ice giants. And I was just thinking about that earlier today, about how many of you in the room have memories before 1995 and how many of you have memories after 1995. And just thinking that those of you with memories before 1995, you have memories from before we knew there were planets outside of the solar system. I'm among the lucky that do remember what it was to live in a world without the knowledge that there were exoplanets, and just thinking that this had to be the standard picture of planets. And yeah, this is how things had to fit. We have the sun, Earth, Mars, Mercury, Jupiter, and it's this kind of like the picture that we were trying to fit into our knowledge of the universe. To me, this is kind of like saying that there had to be planets that were like dogs, planets that were like monkeys, planets that were like beavers, and planets like that were like ducks. This is, imagine that you are the first explorers going into a new continent, and you're trying to describe the fauna in that new continent. And these are all the animals that you know. So you expect to find new types of dogs, new types of monkeys, new types of beavers, new types of ducks, and you're trying to do that. So a lot of what we've done as a field is basically not classify animals, but classify planets. And we've been trying to classify them as rocky, gas giants, and ice giants. And the surprising thing in 1995 is when the discovery of 51 Peg comes, where we find a planet, and I say we as the royal we, when it was actually Michel Mayor and Didier Queloz, find a planet that is about like half the size of Jupiter. It has a 4-day year. It takes 4 days to go around its star. It's about 10% the distance that Mercury is to the sun, with temperatures above 1,000 Celsius. This is about like what, 2,000 or plus Fahrenheit, 1,300 Kelvin. It's super close into its to its star. It's highly irradiated. It's a gas giant. This does not fit our picture. So this is like, again, being an explorer, you get to the new continent and suddenly you find a platypus. You're like, what the heck is going on? It has parts that look like a duck. It has parts that look like a beaver. It's not here. It's not there. So we found something that does not fit our picture of how the universe works. So suddenly we realize that there is a lot of diversity, and that since then, I think when it comes to planetary sciences and exoplanets, nature has been surprising us. And that planets found outside of our solar system are more diverse than previously thought. The idea that currently, with the knowledge that we have after 30 years of this, is that almost the solar system is an anomaly. Finding something that looks like the solar system is something that we haven't been able to do. So yeah, this is super exciting because there is more out there. There is more diversity. And that is one of the things that I love about this field. I want to talk very briefly about how we find exoplanets to give you a little bit of context of how these numbers have come to be. And these are the 6 general ways that we can find planets: direct imaging, radial velocity, the transit method, gravitational microlensing, transit timing variations, astrometry. But I'll just briefly talk about the 3 big ones, the ones that are easier for me to explain and for me to understand. Starting with direct imaging, which I think is what you would do if you're like, oh, I'm going to find a planet, then I'm just going to point my telescope and see if I see something orbiting a star. So here we have this famous system is one of the first direct imaging planets with systems with 3 planets. We have planet C, E, and D. And it's usually really good for giant planets that are very far from their host stars. And it's easy to find them because they radiate a lot of light because they're very hot. And in terms of why they are so hot, it's because they're young planets. They just form, we think, from this gas cloud, and they're just like gravitationally collapsing, and they're baby planets, effectively. And basically what we try to do is that we mask the star, we block it, we kind of like almost literally block the sun with one finger. And our current ability is to detect a signal of 1 part per million, which is just outstanding for me, just to be able to, I don't know, whatever you want to think of, right? Like a million grains of rice and just like pull out the one that is black, or just a signal of 1 per million is fantastic. But the issue here is that because this is such a big signal, 1 in a million, we are limited to these very hot, very giant Jupiter-like planets, and we haven't been able to directly image something like the Earth. Detecting something like Earth around a sun-like star would require something like 1 part per 10 billion. So these just become extremely more difficult things to do. But I mean, that would be ultimately the goal, right? How do you block the star and how do you develop the technology to do so is something that we as a field are working on. The other way is the radial velocity. And actually, this one is the way that the first planet was found. It's the mixture of gravity and Doppler shift. So we know that the planet is orbiting the star, but as you all know, the system is co-orbiting their center of mass. So it's not only the planet that is being tugged by the star, but the star is also being tugged away and towards us because of the motion of the planet. And with that, we see the spectrum of the star. And those lights that come from the spectrum of the star move kind of like away and towards us. This is the blue shift and red shift. And I'm sure you have explained it before, where you have the sound from the siren going down the street and you hear it like getting really high pitch and then low pitch. We are basically looking at that with light. And just by looking at this motion of the spectrum of the star moving away and towards us, we can infer that there must be a planet that caused that wobble. And this is how it looks, right? Like we have the velocity going away from us and then towards us. And detecting this 51 peg planet required measuring a velocity of 59 meters per second with a precision of 13 meters per second. And please forgive me, I am very bad with freedom units, so that I'm using meters per second and not miles per hours. So I Googled earlier, like, what is 59 meters per second equivalent to? And Wolfram Alpha says that 59 meters per second is the terminal velocity of a skydiver. So if you grab yourself and jump out of a plane, hopefully with a parachute, the terminal velocity that you'll find is 59 meters per second, and just measuring that downward velocity that you have is the velocity that was required to, or is the velocity that 51 peg has because of the planet going around it. Currently, we can measure a velocity of a couple meters per second, so we've gotten down by an order of magnitude a little bit more, with a precision of plus or minus 1 meter per second. But in order to detect an Earth-like planet around a sun-like star, we will be requiring to measure velocities of 10 centimeters per second. These are like super tiny velocities. So it will be a challenge. But again, because we want to find whether we're alone in the universe or not, and whether there's other Earth-like planets, this is what the field is working towards. And it looks like it will be doable in the next 5 to 10 years. There's a lot of conferences going on, and people say that, yeah, the technology is being developed for this. And the one that I work with the most is the transit one, because I work on this. To me, it's the easiest one to think of, but it's just effectively we're looking at the eclipses of other systems. We're pointing our telescopes at a star, and then suddenly we see a planet that goes in front of it. And as a planet goes in front of a star, the amount of light that we get from that star diminishes ever so slightly. And that fractional amount gives us the idea that there was an object of a given size blocking an amount of light, and that object, we can infer that it was a planet. So we are not seeing the planet, we are inferring the presence that there must have been a planet that caused that. And usually a Jupiter-sized planet around a sun-like star requires measuring about a 1% signal. So that's why we have found a lot of Jupiter-like planets through the system through the transit method, because it's relatively easy to find a 1% signal. But measuring an Earth-like planet around the sun would be about 84 parts per million. So that is getting to a very, very, very challenging amount of relative changing brightness. So here is one for like one of the most famous or infamous, depending on who you are talking to. This is TRAPPIST, the TRAPPIST system. And you see that if this is the amount of light that we were getting, and just to confirm, can you see my cursor? Or do I need to?
Yes.
Yep. Cool. Actually, just use these laser pointer. But yeah, to me, if you squint, this could be a flat line. So just to be able to measure like boop, this super tiny dip, this is so cool. But this is just for a very, very tiny planet around a very tiny star. So yeah, I just want you to keep in mind about how tiny these signals are. And one of my first things that I did with outreach was just looking at the Mercury transit, and I'm sure that many of you in that room did some outreach stuff for this transit. And this picture that Nilay Scored posted online, and you see that tiny, tiny little dot, and that is Mercury, right? So just being able to measure how much light we stopped receiving from that star because of a planet going around it, at that precision is fantastic. Now, I can get into the details of this, but also thinking about like, what if there's star spots, or like the star is like having flares, and what if the flare is the size of Mercury, right? How could you get that signature blended in and distract you or make your detections more difficult? So far, what we have found, this is the orbital period, or how many days it takes to go around the star. So you see that Earth is on 365 days versus the size. So Earth is 1 Earth radius, Jupiter is 10 Earth radius. So we have the solar system, here's Mercury. And this is what we found. And this is a little bit out of date, but you see that we have found a lot of planets that are very close to their star, much closer than Mercury is. Some rogue ones, some with direct imaging that are very far out, about the size of Jupiter. And we basically, here is 51 Peg. This is part of that family. We categorize them as the hot Jupiters, Jupiter-sized like planets that are very hot. We have the rocky planets that are roughly in the ballpark on the size and mass of Earth, with periods of hundreds of days to tens of days. Actually, very few of them have been on the size of the Earth with periods of hundreds of days, most of it around like Mercury-like periods. Lava worlds that are so close that their surfaces, their rocky surfaces, must be melted. And this weird category that we really don't have in the solar system between the size of Neptune and Earth, that are ocean worlds and ice giants, that we don't quite understand because we don't have one in the solar system. So we don't know if they're like upscaled, larger versions of the Earth, or if they're mini versions of Neptunes, hence what we call them mini Neptunes, many of these. And we also have the cold gas giants that are very familiar to us because we have some in our system. I also like this little animation. You see that the counter here is going up on years and how many planets we have found. And this is showing us where in our galaxy, roughly, we have been finding these planets. So this stops in 2019. But yeah, you see that it has been all around our local neighborhood. It's very close to the sun. It's been a few hundred light years, 100 light years, around 480 light years And this counter stopped at 3,027 planets. But I love this plot because this is kind of like the cumulative number of exoplanets is a function of year. And you see that this was almost exponential, right? It looked like with the Kepler era, this Kepler Space Telescope, we just like had a huge increase in planets, and we were just like going up and up and up and up in the number of planets that we found. So the lesson number 2 is that to date, there are 5,419 confirmed planets, and the discovery trend almost seems exponential. I took the time to cross-check my numbers last night. So last night, the number was 5,419. But to give you an idea, this is what I use, the NASA Exoplanet Archive. And in just one day, we went up by another 19 planets. So whatever I tell you today is going to be out of date tomorrow. So it's just, I find it impressive that, again, in 24 hours, we have 19 more planets that have been confirmed. Oh, and we also look at the number of candidates, almost 7,000, let me round it up, 7,000 planet candidates. How many of those are false positives or not? Well, we'll talk more about that in a little bit. But yeah, we have plenty of gas giant analogs. Statistically speaking, if you like me make broad stroke statements, there is at least one planet per star in the sky. And the majority of the planets that we have found as a population are planets somewhere between Earth and Neptune in terms of size. So it is so cool that the most abundant planet is one that we don't have in our solar system. Isn't that just like crazy? So that's lesson number 2. And the cool thing, and the reason why I have a job, is because now we're not only like counting planets and just playing bingo and being like, yeah, sure, I found another one, but it's because now we can characterize them. And as I was showing you earlier that we have the amount of light that we come from the star, but as the transit goes in, you have a dip. But also as the planet is about to go behind the star, you can also get a tiny little dip in the amount of light, because now you don't have the contribution from the planet. You can calculate the spectrum of that. And from the spectrum is that we characterize our atmosphere. So for the rest of the talk, I will be focusing on characterization of exoplanets through the transit method. And for the majority of the talk is when the planets go in front of the star. So effectively an eclipse. And the question that we want to answer is, what are these planets made of? Yes. And I know all of you know this. I'd just be remiss if I don't talk about the electromagnetic spectrum. You know that we look at things in the sky through their light emission, but I'm just showing this because I want to tell you that for the most part, all of the characterization of the exoplanets that we do are really in the infrared and visible. We just look at these very, very tiny little slits of the EM spectrum. But there is a lot of work into looking to the X-ray emissions and some of the ultraviolet. Actually, there is ultraviolet spectrum, but some of the X-ray is really cool because you're trying to look into the auroras of exoplanets. So I find that really exciting, but I don't have time to go into every single one of this, but I just want to mention that we're going mostly into the infrared, the visible, and the ultraviolet. And this particular animation, okay, so I already told you the primary eclipse, secondary eclipse. I'm going to focus on the primary eclipse. I think this one drives the point that as a planet is going in front of the star, some of the light gets absorbed by the atmosphere and some of it gets transmitted through the atmosphere. So we are not really looking at planet light. We're not looking at the light that the planet is giving out, but we're looking at the light from the star as it goes through the planet atmosphere. So we're looking at the starlight minus the imprint, the fingerprint of the planet. And that's what we're trying to figure out. In reality, what this really means is that the apparent size of the planet changes depending on the wavelength, depends on the color that we look at things. So in this particular animation, the planet is the smallest in the green, therefore it blocks the least amount of light, but in the orange or in the yellow, it blocks the most amount of light because the apparent size of the planet is the largest. When I started working on this, I was like, yeah, sure, that sounds cool, but it kind of like felt like a trick. I was like, yeah, sure, I kind of like understand this, but I didn't feel it within my heart. It hadn't like clicked. The moment that it clicked for me is when I saw this image. This is a real color photograph of the Earth with the moon here in the background. This is on real color. And then they took the picture at 8.6 microns. and at 9.6 microns. And if this was an eye exam, I'm just going to go back and forth. You see that the apparent size of the Earth is changing. Earth is not getting fatter and thinner. It didn't go on Weight Watchers. We're looking at the ozone absorption band. And so if we're able to see this absorption band at 9.6 microns, we would be able to find ozone on an exoplanet. So I find it particularly exciting that we observe this same effect on planets very, very far away from our solar system. So by looking at that apparent change in size, we can see the different chemical species and the pressure temperature profiles, the composition, the climate, the weather of these planets. One of the things that I hope to tell you by the end of this is that water has been detected in many of the planets. The water is all over the place. But we've had first detections of lithium, of aluminum oxide, of sodium, of potassium, carbon dioxide, now carbon monoxide. We are seeing that these atmospheres are very diverse. The fact that they have titanium oxide, I'm just going to go on a little bit of a tangent. I had an allergic reaction to some sunscreen that I was wearing the other day and went to the doctor, and turns out that I'm allergic to titanium oxide. And it's like, oh, that's interesting, because titanium oxide is also what we've been finding on these exoplanets. So we're finding like sunscreen protector there. We're finding clouds made out of rubidium and zirconium, and it's just, anyways. And this is the type of data that we were getting almost 10 years ago. Yes, 10 years ago. This is from a planet called OAS 19b, this color and the size of the planet. But yeah, effectively, we're looking at different colors, and the apparent size of the planet is changing depending on the wavelength. So here you see that here it's smaller, here it's bigger. And 10 years later, and I hope I got myself a little bit ahead. I want you to keep this picture in the back of your mind. 2, 4, 6 data points. This is the state of the art 10 years ago. But we want to understand what chemical species are in the exoplanets. And for that, we need to go to the basics, to the bane of my existence. As a toddler, I hated this game. So it's quite ironic that now this is my life. But, that bucket where you have to like fit in the figures and be like, yeah, is it a triangle? And if it fits, it sits. So therefore it's right. That is ultimately what my day-to-day job entails. So it's because we have the shapes of different molecules. We have the size of different molecules as a function of wavelength, as a function of color, because we are able to, again, I don't do this work, colleagues do that. In laboratories here on Earth, they fill these containers with water gas or methane or CO2, whatever. They shoot a laser at it at different wavelengths, and they see how it absorbs. And it sees that, yeah, it has a particular cross-section, it has a particular size. And so let's think about them as these pieces on the bucket. And this is what 10 years later we can get. I'm just going to go back and forth. The fact that we went from this to this in 10 years, I just find also super exciting. So this is a recently published spectrum with near-spec prism on board of JWST of WASP-39. And again, we're measuring the planet size as a function of color, as a function of wavelength. And we see that we have this massive increase in planetary size, this feature around 4.3, 4.4 microns. So let's just go back to the basics and let's see what fits. And this is what the cross-section of methane looks like. And you're like, sure, it kind of like fits here, but not very well. You go to water and you're like, okay, this is what water absorbs maybe here, but not really quite over there. And you're like CO2, and you're like, actually, that's not a bad fit, right? Like you got this, and you got the big bump around 4.3, 4.4. And yeah, sure, there's this thing, but overall, the CO2 thing is going on. So if you agree with me and you're like, yeah, sure, that looks like CO2. Well, congratulations, you are now worthy of getting a press release, because that's what we did. It's just like, does it fit? Does it match? Yeah. Therefore, NASA's Webb detects carbon dioxide in an exoplanet atmosphere, and it was a first. Right, this is the big first result that we got from the JWST telescope, and it was the detection of carbon dioxide for the first time in an exoplanet. But ultimately, we just don't want to tell you there is carbon monoxide, carbon dioxide. We want to tell you how much of it there is over there. And we use something that in the field we call a retrieval. If you've ever done a line fit regression, you've done a retrieval. It is effectively a procedure to try to infer the atmospheric properties, as I was telling you, the composition, what is the temperature structure, are there inversions, are there clouds, are there hazes, from the observations like the spectrum that I was showing you. And what you do is that you run a large ensemble of models. You do your calculations of radiative transfer, your physics, whatever you think about how an atmosphere should behave thousands or millions of times, and you try to explore a parameter space. So let's try to do a retrieval in real time here together. This is a particular spectrum, and we see that at this particular wavelength, at 1.3, 1.4 microns, there is a big increase in size. And actually, if I go back, I shouldn't be going back and forth. I'm going to make you feel DC, but around 1.4 microns, water absorbs. So we could play this game and we see that, okay, this is water. I know that water is going to be absorbing, but I want to know how much water is. So this is like knobs. I'm just going to play with how much water I put into my model at a given temperature. Let's say that I run my model and you're like, yeah, sure, that's not a bad model. So for this given amount of water and for this particular temperature, I have a good fit. And therefore, I'm going to put a green tick on this, a green cross. This is a good fit. I'm going to change my model ever so slightly. I think like maybe increase the temperature a little bit. It's still a good fit. It's missing a little bit of these points, but this is okay. But now let's just increase the water by a lot. And then we see that by increasing the amount of water, I'm missing all these features. So this one that has a lot of water does not fit my data very well. So we're going to do that many, many, many times. We're going to try. And for every model that works very well, I'm going to put like green little crosses. And for ones that don't work very well, I'm going to put red crosses. This is how I'm exploring that parameter space. And from this, I can choose the model in the middle of it. I can choose a median. I can plot it. And I can start drawing contours and be like, oh, within this nth percentile, the 68th percentile, this is the family of models that can explain it. And I can do a 2 sigma. So I can have a contour of all the possible models that explain it. And I purposely did this so cartoonesque because this is effectively what we're doing. This is what it looks in reality. This is a posterior distribution, and this is actually what we got for some measurements of a planet, amount of water and temperature. And what we do is that we project them onto the other axis. So we project into the amount of temperature, and this is probability density. So basically, how many models gave you that temperature, and we project them onto the other angle. But we flip them to make them easy to read. And congratulations, you've created what we called your first corner plot. But this is how you would know that not only did you detect water, but now you know with certain confidence how much water are in these particular exoplanets. So the desired output is that we want to give you a family of models. We want to give some sort of like confidence interval of like, oh, there should be this much water. There should be some sodium, some potassium, because that is how we explain our observations. We want to also tell you what the pressure, temperature, structure of this planet is. Oh, like it's 1200 Kelvin at like 1 bar, 1 millibar, and some distributions of how much clouds or whatever we're trying to understand about this planet. But ultimately, one of the things that we want to go is not only tell you what the composition is, but what does it tell us about exoplanets in general? Like, cool story, bro, you found water, but what does that tell us about the universe in general, right? And the picture of exoplanets is very convoluted. And it's not convoluted, sorry, it's very rich in information. That is what I'm trying to say. And depending on the wavelengths that we look, if we look at the ultraviolet, we can measure the atmospheric escape. And if we went to the X-rays and the gamma rays and that stuff, maybe you can measure the upper atmosphere and maybe the auroras. You can measure the photochemistry. You can measure the presence of clouds, vertical mixing, all these processes that we see on Earth's atmosphere, the thermal inversions. And one day, we hope that through these measurements and putting this picture together, we will be able to understand what makes a planet habitable, which is a deep question that I don't think we as a community, we agree on what makes a planet habitable. But one of the things that we're trying to do is trying to put this in the context of how planets form and what is their evolution. We're trying to basically say, if I observe the composition of a planet now, it kind of tells me where it was. Kind of like when you see someone walking into the room after a blizzard and you know them covered in snow, you know they must have walked past a very snowy path or it was snowing outside. We're trying to see that if a planet comes with a lot of water, well, it moved through a path that had a lot of water. So it kind of like tells you what's going on. And here in astronomer, in the theoretical astronomers, we call this the core accretion model of planet formation. This is just a fancy way to say that planets that are more massive, the more massive the planet, it looks to be the less rich in metals because it has a lot of hydrogen and helium. So you know that as astronomers, everything that is not hydrogen and helium is a metal. But if you have less gas, you have a lot of rock, then you're more metal rich. So smaller planets have less of an envelope and they're more metal rich. So what this means is that we see this type of behavior in the solar system. This gray line is the amount of metals that the sun has. This is the solar value. And we see that Jupiter, Saturn, Uranus, and Neptune are enriched. They are higher in their particular metallicity. And we see this particular slope. We see this particular trend that, again, the bigger the planet, the more massive, the less metal it has, and the smaller it goes, the more massive it goes. So we see this in the solar system with the amount of methane that we have measured. So the question we have here is, if we look at exoplanets, do they fit this picture or not? If they fit this picture, we could assume, perhaps, that planets formed in the same way. But if they don't fit the picture, maybe this tells us that they formed in a different way. But what is crazy about this, I think, sorry, was there something going on in the background? Any questions?
Oh, I think somebody accidentally unmuted their microphone.
Oh, cool. The cool thing is that we cannot do a one-to-one comparison because one of the most available gases that we see for exoplanets is water, but we don't know how much water there is in our solar system. Despite the fact that we've seen Pioneer and Galileo and Juno, we still don't know how much water the ice and gas giants in our solar system have. But we do know it about these exoplanets. And I hope some of you are puzzled, and I was puzzled when I learned about this, but I think in the end it makes sense because the exoplanets that we're seeing, they're very close to their stars, they're very hot, so the water is evaporated, it's in gas, so it's easy to see. Whereas the gas giants in our solar system are very far out, are very cold, the water is condensed out, it's very deep in the atmosphere, so it's being very difficult to measure it. So we don't have an apples to apples comparison, we have to measure the amount of methane and assume that it's close to the amount of water that we see for the exoplanets. And that is kind of like a lot of the work that I've been doing, trying to understand from the amount of water that we measure and the amount of sodium that we measure and the amount of potassium that we measure, do planets match the story that we get for the solar system? Or one of the things that I did is that this retrieval method that I explained to you, which ran the largest survey that we had with measurements from laboratories about how sodium and potassium and water behave on labs to understand how the spectra looks at different temperatures and different pressures. And we looked at the largest population of planets that we had available in 2019. This is the plot of planets that had transmission spectrum with Hubble and spectrum from the ground. And in total, we analyzed a full sample of 19 planets. And it's perhaps puzzling that out of the 5,000 almost that I was telling you about, only 19 had good spectrum. But it's because it's difficult to measure this on these wavelengths. And from very cool planets that were about like room temperature, 300 Kelvin, which is like 80 Fahrenheit, to 2700 Kelvin, which is about like 4,500 Fahrenheit. So very scorching planets. And in all of this, what we did is that we found that 6 planets had strong detections of sodium in their atmosphere, 6 with strong detections of potassium, and 14 with strong detections of water. So with these detections of water, this is what they look like. And I hope that some of you laughed, you're like, this water, and that's kind of like what I'm trying to tell you, right? Like some of them, we do see very clearly a feature, a bump around 1.4 microns, that is the telltale of water. But for some of them, we barely see it. Some of them, they look very flat. So the amount of water in these planets comes in all shapes and sizes and flavors. But there is a wide variety, and all of them have something that resembles this bump around 1.4 microns. And this is the amount of sodium and potassium, these little 2 peaks that we see in the spectrum. Are sodium and potassium. You see that some of them have a lot of sodium, but have very little potassium. Some of them you're like, I don't know if I believe you, Luis. You're just looking at squiggles and wiggles. My child can draw better than you, and that's probably right. You have also here lithium. So we were trying to measure all of this. And we have the solar system trend. And now let's put the measurements of water that we found. And this is where we would take bets to tell you for you to tell me like, ooh, do they match or do they not match the solar system? I'm not there and I cannot hear you very well. So I'll just show you that this is what we got. It's a little bit of all over the place. The planets that have the best measurement, the smallest error bars, you see that they're very, very below the solar line. Some of them are consistent with the line with huge error bars. This one has massive error bars. But if we try to fit a trend like we do to the solar system, we have the same type of like overall behavior that it gets bigger with smaller mass, but its overall offset kind of like below it. So the way that the news took this is like water is common in alien planets, and if Fox News says it, it must be true. It says that yeah, water was common, but it came in smaller amounts than we expected. It was water common, yet scarce. So we had this increasing amount of water with decreasing mass, which tells us that there seems to be less oxygen relative to other species. It seems like these planets formed in an environment where there was not a lot of oxygen. Now, what does this tell us about planet formation? Did these planets form the same way or not? It seems to be that there is different ways for planets to form, and the planets that we're seeing form in different ways. And at this point, you're like, well, that's not surprising. They don't look like anything in the solar system. They're not in the same configuration. Of course, they didn't form in the same way. But just getting the evidence to say, yes, planets form in different ways. And so far, the solar system seems to be unique in its own ways is interesting. With the big caveat that this is not a one-to-one comparison. And up until what is being published right now, we don't have measurements of methane on these exoplanets. But this is, again, old news, because now we have the James Webb Space Telescope, which is going to give us unprecedented observations that are currently challenging our understanding of exoplanetary sciences. All these measurements that I showed you were with Hubble, which has a mirror about like 2.4 meters in diameter, whereas JWST, the primary mirror, is 6.5 meters tall, which is massive. And because units are not my forte, I like to think of it as, it's 3 Shaquille O'Neals on top of each other. That is how big JWST is. So next time you see Shaq, you're like, oh my God, if I stack 3 of you, that is JWST. And that to me, that was like, now that is a big mirror. So with 3 Shaqs on top of each other, we can start building better and bigger pictures of planets. I'm going to show you a small video right now, but this is the spectrum that we had for this particular planet, WASP-39. And you see the wiggles here. And with this particular wiggle is that we say, oh, there is water in this planet. But let me show you what JWST can do. JWST can measure with tighter error bars the same bumps and wiggles, but it's suddenly giving us information at wavelengths that we were not looking at before, and just complete our picture. And here is now with G395, it's another instrument. And you see this is with Spitzer, and it's like, wow, it's matching so well. This is a CO2 bump that earlier you agreed with me that it was CO2, and therefore you had a press release. This again, how many bumps of water? So now we're getting more confident and more, it feels better in our tummies that we are repeating observations with a bigger telescope, with tighter error bars, and we're learning so much more. This is a family portrait for all the instruments on board JWST. We've been finding sodium, the CO2 that I told you earlier, potassium, water, carbon dioxide, and this particular bump that is the one that I showed you earlier that I was like, it doesn't fit very well. This is called sulfur dioxide, SO2, which is a product of photochemistry. That means that sulfur is in the planet. It's being dissociated because of rays from its star, and we're getting new species, and we're seeing new chemical processes that we hadn't seen before in these type of exoplanets. And this is what the entire data set looks on top of each other. This is something that we're working on and trying to understand what each wiggle tells us and how much of the particular thing is there. This is kind of like what our models are looking at. It's just fantastic, the agreement that we have between our data and our models. And the fact that we're able to see several bumps that tell us that there is indeed water at about 1%, that there is a sulfur dioxide, there's carbon dioxide, there's sodium, and there's potassium. And I also wanted to show you this result. It was published earlier this week. There's so many results that I would love to show you. It's just like we're working on getting them out, but we are able now to see 3-dimensional maps of the planets, basically looking at the brightness temperature of the planet as a function of time, and see how the planet 2 hours later, when it comes up from the other side of the star, the brightness is increasing as a function of time. And by looking at how the brightness of the planet changes as a function of time, we're effectively being able to see where the hot spots, where the hot material is, and build these now 3D pictures of what planets look like. And we are able now to decipher whether there's Alf, that's cute. Whether there's winds moving material from one side to the other of the planet. I like to stop here. Yeah, we see the contrast between what we call the day side that is highly irradiated, the night side, how the clouds will be forming on one side, and the fact that there is an eternal day side is just very, very interesting. And that again, we can measure. Let me go to the next slide. It's water again, but now we're measuring the amount of water as a function of latitude and longitude. So we are making these weather maps of these particular planets, and I find that very, very exciting, because that is ultimately helping us understand how weather and how climate forms in these planets that are nothing like what we have in the solar system. I wanted to finish very briefly with your role in this. I think your role in this can be much bigger than what I have in the next couple slides. These are resources that I found also very useful. If you thought that I just had a bunch of mumbo jumbo for the last 40 minutes, you can actually go to exoplanets.nasa.gov and look at the latest missions and the latest results that they're having. You'll see a lot of our press releases. One of the cool things that some friends like to do in their free time is to help spot exoplanets in the measurements from TESS. You can help through Planet Hunters or Zoo Universe and take some free time and help us find, and again, I use help us as a royal we, I don't do this, colleagues do this, where they need the community to help us find where in these light curves there's something funky. And while they train a lot of algorithms and artificial intelligence is getting better, there is nothing like the human mind to spot this wiggles and be like, hey, I found a planet. So it would be cool if soon we hear from the Omaha Astro Society that you all found several planets and brown dwarfs. I love a lot the JPL ICE exoplanets and ICE on exoplanets, because it has really wonderful animations and 3D renderings of these planets. So I also find that very good, I think, for groups like yours that are experts in outreach. And just some concluding thoughts. I really like this field because nature keeps surprising us, and you can have me again in a year or another expert in exoplanets, and you will be hearing about some completely new results, and everything that I've told you today will be outdated, because that's how fast the field is moving. There is so many surprises going on here because we have thousands of planets, and there are so many more that are waiting to be discovered. And the cool thing, as I keep telling you, is that not only can we detect the planets, but now we're able to measure what they're made of, make maps of them, see their weather, see where their winds are, see what their clouds are made of, see how much water is in the equator versus the pole, and then put it all together and understand what planets tells us as a population, and tell us whether we're unique in the solar system, whether the solar system is unique. And many of these have been characterized. There's water in all over the place. And soon enough, there is the possibility of water in quote unquote habitable worlds. We still have to really understand what does habitability mean. And for now, it just means whether liquid water could be at its surface. But I think that together, working with chemists, with biologists, with sociologists, with geophysicists, and with astronomers, I think it's within our lifetime that we may discover surprising worlds, perhaps those including other life forms. I think that we're closer than ever to getting an answer of whether we're alone in the universe. And what excites me the most is that I think that colleagues like you can play a significant role, and are playing a significant role, by being excited, by thinking about this, and by playing a significant role in just keeping up with all these exciting results. So I just wanted to thank you again for having me, and I welcome any questions that you may have.
Any questions for Dr. Wilbanks?
Yeah, I have a question. You know that graph that you showed that presented the most common exoplanets that are currently discovered, you know, the prevalence of the planets? Yeah, that one. I was really surprised to see that there were not many exoplanets that fell in the category of the cold gas giants like Jupiter and Saturn. And I found that very surprising. And I guess I'd like your opinion on that. I mean, is that a result of the observational limitations that we currently have in detecting exoplanets, or is that a real result? And also, does that give us clues as to how our solar system could have been formed, and maybe that those cold gas giants were sort of captured in the formation of our solar system?
You hit the nail right in the head. This is just a result of our inability currently. It's just the limitations of our telescopes that we are trying to detect a very faint signal. As I was saying, this is just like parts in billions. So they're very far, they're very cold. So we are not able to measure them. And the things that are easier to spot is something that is going very fast. So you get a lot of measurements in a couple nights and you're able to confirm it, right? A planet that takes 10,000 days or 100,000 days for you to be lucky to just be able to look at it at the right time that it's transiting in front of its star, it would just it's just very lucky, right? And then on top of that, let's say that for whatever reason you're able to measure that, you would have to wait another 100,000 years to be able, 100,000 days, to be able to measure it again and be able to convince the community that it's there. But I think that will soon change. As I was showing you here, a lot of them have been in our local neighborhood. There was a result earlier this week or last week about the Roman Space Telescope, and that is going to do a lot of gravitational lensing. So it will be observing towards the galactic bulge, and towards the galactic bulge, there's obviously more stars, so there will be more probabilities of lensing. And they were saying that the latest or the latest estimates that we will be having 10,000 or 50,000 new planets very, very quickly. And that within our lifetime, I don't quote me on this, but I think it was like easily 100 to 500,000 planets. And that is where we'll be able to see this cold gas giants, especially when we go to bigger instruments with other techniques that do not rely on just like luck of finding on transit and just being able to see it then very far. And a lot of it will also come from the direct imaging method. If we're able to block this amount of light, we'll be able to block the stars a little bit better. We will be able to see the very far out planets because currently we're like limited by this specking. So technology will help, new missions will help. So I don't think this is nature telling us it's revealing itself to us. This is just what we're able to see right now.
Wow.
Thank you.
Thank you.
I got a question, Dr. Wellbanks, if I can.
Of course.
For the planets that you've been studying with all these I guess studies, are you finding they're in multi-planet systems, or a lot of these just single planet systems? And if it's a multi-planet, how is that affecting your observational data? Are you finding kind of things overlapping? If multiple planets are transiting behind or in front at the same time, kind of how does that change everything that you get for data?
Yeah, so one of the most challenging ones right now, because they're exciting, are the TRAPPIST system, which I had somewhere over here that had the light curve. TRAPPIST has the 7 planets. They're all Earth-like around a very tiny star. But indeed, what you're talking about is just like, we need to make sure that we get your timings correctly, right? Because say that we want to point a very expensive telescope like JWST. I was being told that like each hour of operation is on the order of like tens of millions of dollars. So if you have this very fancy toy, $10 million, and they give you the one shot, your one opportunity, going full Eminem in here. And then like they tell you like, okay, we're gonna start at this start, just tell me when. If you don't get the timing right, you just wasted a lot of time and you just got nothing. Right, so you just got to make sure that you know and you measure with all these methods, and you do a lot of like your rigorous job and cross validations to, yes, make sure that you are able to measure it at the right time, and that you're able to see that this little tiny movement is because of a planet, right? Like, but then let's choose this epoch. This is, so you see that there was 0, -1, -2. This is like how many times they had to look at it, and they have to look at it with a lot of instruments. But how do you figure them out? Like, for example, here that is going up, was this noise, or was this the other planet that was affecting the information? Or, as I was saying, like, was there a flare, a spot that happened on the star that affected your information? So there is a lot of work on trying to think about the systematics and making sure that we clean that information. So for us to get the very cool result that we like, is there water on these very Earth-like planets in the habitable zone of their star? We will need a lot of transit with a lot of like very careful measurements and follow-up. So we may be observing with JWC, but also have to observe with the ground to make sure that we have a two-pronged effort to make sure that what we're getting is true. So yes, there are multiplanetary systems. There are observations for these multiplanetary systems. They take a lot of work from the community for validations, for vetting. But for many of these, they may be in planetary systems with, or multiplanetary systems, but maybe we don't know them, right? For example, let's just choose a planet here in random, right? This is a planet that we know of, but maybe we haven't been able to find its companion that is very far out and it hasn't been transiting or whatever. So many of these planets have a companion. So the hand wavy demographics is that every single star has at least one planet. But then we can think that for many of these planets, they have siblings going on around at different rates, and how we find them and how we account for them is a constant area of work for all of us.
Can I ask a follow-up question to that then?
Yeah, I'm happy to. Yes, answer.
So say you have you're looking at one of those multi-planet systems, you know, you have a few of the planets in there. Is there anything that shows up that tells you that there's a potential for like a asteroid belt or something, like there's a big gap in between, you know, two planets, and there's any evidence that there could be asteroids in between them? Is there anything in the data that would show up for something like that? Or is that still kind of a little far off for our systems and our measurement tools?
That is not my area of expertise. That is not something that I'll tell you, like, this is how I solve for this. I can tell you what I know from like working in this field in the literature. And it is that we haven't had a confirmed measurement of an asteroid belt. We talk about like the exosody and like the zodiacal dust, and yeah, like just like you do for these telescopes. So we think that yes, there is dust around these planets and some of these, dust around these systems, and that can affect our measurements. But there is a lot of work going on. There's several groups going on very hard on finding moons, exomoons. So you can imagine you have your like little transit. There's a transit within the transit. So you have a slight wiggle within the wiggle. And that is because, well, perhaps there is a moon going on around that planet, right? And so you can then make the next big step and say, well, maybe the planet itself is not habitable because it's so close, but maybe the moon that is a little bit further, it is within the right region where it may be habitable. So a lot of thinking is about going into the moons and perhaps thinking about the own moons in our solar system, and maybe like Enceladus and Io and like all these moons. Maybe that's where the life is in our solar system. But the other thing is that there's issues about how puffy these planets look. Many of these planets seem to be bigger in terms of their radius than we expect them to be because of the models that we have about how nature works. So it can mean two things, well, many things. One of them is that we are very bad at our models and we should get a different job. Very likely we could be doing that. The other one is that they are being inflated so much because they are getting a lot of light. They're basically hot, they're bloated. Like me when I go to the beach, just like it's really, really hot, you get really, really big in radius. But the other thing is could be like, we are measuring actually the rings around planets. So we're not looking at the planet, but we're looking at the planet with its rings. So that's why it seems to be big. So there's actually some papers that are thinking about how can we distinguish that? And then we have to look at the signatures of rings at different wavelengths. So rings actually seem to have, because they're made out of dust and little rocks and little pebbles, they would have measurements in the ultraviolet and the optical. So we would be able to see what the composition of these ices and gases and dusts are made out of and distinguish them from the atmospheric signature from the planet. So I think all of this together is pointing towards like little by little making the advancements of measuring this. And also there's a complication of what are the chances of these particular rings being aligned in our line of sight, right? What if the ring of asteroids is over here and we're seeing some of these planets are in like very polar orbits? So also the chances of making sure that they're in the right configuration. If they are just in our line of sight, it would be presumably always constantly blocking the same amount of light. But because this is such a thin disk and it's very tiny particles, it will be negligible given our current observational limitations.
Perfect. Thank you for answering that.
No more questions from the room or online? Great,
Thank you.
thank you. That was awesome.
Thank you very much for having me. I hope you have a lovely evening. Thank you for inviting me, and I hope to chat to you very soon.
Hey, thank you very much.
Again.
Appreciate it. Wonderful.
Take a 10-minute break, everybody. I'm gonna pause the recording.
You said that was.
Continuing on. Yeah. Astro Park usage. I was there. There were 18 people at the party. When did you, oh, you were there?
Fleet was there
You were
too.
there? You were there? What about nights that wasn't the party? No. Okay, well, I can probably say pretty good that we're gonna be 18 to 20, so I'm gonna say
Oh,
20.
I think there'd be more than that with the astrophotographers.
Yeah.
Say
Definitely.
25.
25?
Oh, you're 30.
Not selling Astro Park. Do we have any awards?
We do not have any awards. Hopefully we will next month, because I got a submission today.
Ooh, exciting. Thank you.
Serving chair. Okay, I gotta find your slides here. Have a little handheld thing now.
Kind of scary looking.
It is a little scary.
Okay. So June, welcome. You can now start seeing Saturn and Jupiter after midnight. Most of the planets are in the morning, so Neptune, Uranus, and Mercury. Venus is still in the evening, and tonight, if we didn't have clouds or if it's raining outside, we would be able to see Mars in the beehive. But it will still, that's a little picture from Stellarium that I have there. Tomorrow it might still be close to the beehive, but that's pretty much it. Yesterday was another day to look at that. It was not actually in there, but more close to it. Venus is then going to swing by the beehive on the 12th, and a nice conjunction with the moon on the 21st. Next slide, please. We have full moon tomorrow night, new moon on the 18th, and the summer solstice on June 21st. No major meteor showers this month. I think that's all I have. And these were just the references I used.
Cool.
Thank you.
Thank you.
I'm hoping that by having some kind of extension on here, this is a prototype. That it won't wobble as much. When we're going through things. We would be very happy, I think. You can take a picture of this if you want, but.
I won't.
Hey, it's tool time for
I don't
tonight.
think he can.
It's a tool time. Right,
Wow.
oh, yeah, if you've seen the Stellar, there's a lot of outreach options coming up. Yes. And one of the things we did was we put the outreach sign up on the website now. And we got so many people signed up for alerts, and it was amazing.
Yeah. That was fun.
Was it a 1-to-1 for Lawrenson or?
Not quite. I don't think it was quite.
Hmm. Well, would you like to speak about this more than me? No?
Yeah, so a lot of stuff going on, especially later in the month. Tomorrow, there is the Los Hills Conservation, or it's actually the Los Hills Prairie Seminar. So anybody is, welcome to go to that. It's a free seminar about nature and conservation and the history of, that region of Iowa. It's up by Ottawa. It's a 3-day. So it was, yeah, all afternoon today and then all morning and evening tomorrow, and then a bunch of stuff Sunday morning. As well. They're all free activities like nature walks and birding tours and interpretive trail stuff. And then a star party, Saturday night. So if anyone wants to go, we're gonna camp out for that. Just let me know, I'll get you the information. Following up that, the 13th, which will be the Tuesday, week from Tuesday, is our astronomy in the park at Lake Zerinsky. Standard thing, 156th and F Street, the soccer field's there. We'll meet around sunset and hopefully, if you have a telescope and it's nice out, we'll see everyone there. We have the first, hopefully, fingers crossed, since we've had bad weather for all the rest of them. First of our library star parties with the Ralston Public Library on June 16th. That will be held at the Ralston Library and starts at 8:30. Well, that's when we'll start setting up and they'll get there. We'll talk about telescopes, the library telescopes that they have. And some other things as it gets dark, and then once it gets dark, we'll still wait and see. The following night, then, the Saturday, June 17th, is the Bellevue Public Library Star Party, and that's at the Bellevue Public Library in Bellevue, Nebraska, in case you didn't know. Same deal, start at 8:30. See what we can see. Weather dependent, I'll post on Discord. And probably on, have Kim, do it on Facebook. Oh, there you are, I knew you were here somewhere. For any of these that are weather dependent. On the 22nd, John, and you're able to do that, John? John and I could have one or two other volunteers. We're gonna take the Burke Air and Space Academy staff, the teachers and some of the aides and things that they have. And they're going to bring out their big Schmidt-Cassegrain on AVX, and they have a go-to Dobsonian and a couple of Star Sense Explorer refractors. So we're going to set those up and teach them how to use them because they really have no clue what they have or how to use it. And so
The teaching the teacher event.
yeah, so anybody who has experience with SynScan hand controls for that Skywatcher go-to Dob, it's a 10-inch, it's really nice. Or the AVX, setting up the AVX with a big Schmidt-Cassegrain. You're welcome to come out.
Leonard should be an expert on that Skywatcher since he is the big one at the NASA event.
Yeah. So anyways, that's what we got going there. That'll be starting. They're doing like a picnic thing beforehand, and we're gonna meet like 8:30, go over stuff. The next Mahoney State Park Star Party is on Friday, June 23rd, with a cloud out, rain out, weather backup date on the 24th, the following day. We had one a couple weeks ago. It was a lot of fun. It was Memorial Day weekend, so had a really good turnout.
There had to have been more than 100 people there last Friday night.
Great weather, really nice. Got to see a lot of different stuff. Good first quarter win. Then another library star party, June 23rd at 7 o'clock. That's really early.
I probably typed that in wrong.
Yeah, I'm guessing that's gonna be like 8:30 or 9 o'clock. I'll make sure that Kim knows and we can update the Facebook as appropriate. Another Larson Garden Star Party on the 24th at 8:30. Same deal. We go drive back to Rose Garden on load our scopes. They bring a little cart full of people and say, look at the telescopes, and then they go. It's a nice fun thing. Decent location.
7:30?
Yeah, you know,
Those folks pay for
there's a
their
few trips around.
tickets to that event, so they're usually pretty engaged.
Which day would that be?
Fun crowd.
Yeah, the admission garden to present Star Party.
No.
No,
No,
Nice.
in
if
in
you're
fact,
a member volunteering, you do not have to get entry for it. Yes, Louis.
And we got passes to Lorenzen after.
yep,
Afterwards, for
in fact,
volunteering.
they will actually give you an extra set of entrance passes for your time and effort.
So like, did they put your name on it or they just hand it to you?
They
They
gave
just
me a little,
handed it to us.
Okay,
just gave it, yeah,
so if you're already a member, you can pass it on to
well,
somebody.
yeah, take your family or
Nice.
two of your favorite friends.
So I kind of skipped over it, but we were talking about the Mahoney Star Party on June 23rd, and then we talked about the Waterloo Star Party on June 23rd.
It's the same night.
So we are double booked on that due to some miscommunication between John and myself. And then I don't know if you noticed, but the next night is June 24th, the Earth and Garden Star Party and also the Springfield Public Library Star Party. So I apologize for that, but we would like to have at least a few people show up for the library ones. And we're expecting smaller crowds at those, since we haven't done before, at least at those. Particularly at those two libraries, because they're smaller towns. Bellevue and Ralston could be well attended. And then another one in July for, there's a couple other things in July before that. Chris,
You posted something on the Zoom. Was that supposed to be a link? Something?
that is because my laptop was dying and I want to make sure that that was there so I could refer to it
At
a little bit later.
Okay, because it goes to nowhere.
Nope, yeah, it's an activation code for Astrosphere.
Okay, because he sent it out to everyone. There was some questions.
Fair enough, yep. More on that in a moment. That's. Any questions? So yeah, if you go to the website, go to club information. And then go to the outreach sign up, it's the same link, but the form will change as the events change. And we'll keep it updated, and then as soon as you post on that, it'll send us an email so we can put you down and know that you're going to attend. Diana.
Question, the Stella also lists the 4-H Star Party at Schramm Park on Friday, June 16th.
On Friday, June 16th, at the 4-H, actually, I think it's gonna be at Schramm Park and
Yeah,
not,
it's at Schramm Education Center and Park, is that?
yeah,
That's
so
also
it's not
one,
at the old campgrounds like we did last year. In the past, it's actually at the Schramm Park facility. And that's another event in June.
Apologies for not putting that in the
Yeah,
slide.
so busy.
It's been a lot of things to try to compile and put together. It is in our
Oh,
calendar.
yeah, it's the same day as the Ralston Library Star Party.
So that means everybody say it together, double book.
So really relying on your charitable good graces.
Your gracious.
to,
Wonderful.
help man all of these random things. On the good news, you can really just knock out, if anybody hasn't started their outreach award.
Don't have it.
I mean,
End of the
June,
month.
You can do it.
Do 5 in a week and you've got it made.
For those of us who are master outreach award level people and still don't want to count something, the library.
Oh, the
The
library.
library star parties count as library telescope events and would count towards your library telescope award certificates. There's 2 levels of that as well.
Wow.
Yeah.
So I think it's like 20 hours or 30 hours and then
20 and
80 or 20 and 50 or I don't know,
20 is the first one.
20 and then some more.
So if you did some work on a Saturday for 4 or 5 hours,
I had a telescope delivered today. I have 2 more that I'm expecting. For Elmwood, Fort Madison, and some other place in Iowa.
cool.
And that grant was filed for,
Oh, that's right. We can bring that up in the business sections.
Thank you, Mike
That's a lot.
Stafford, and I did update it with the Stella this time.
Ooh.
See what we got here. Couple minor changes here on the slide because these came in shortly after the deadline. Coronado's back, so I have a couple of people on deck waiting for that, so let me know when you're ready to pick it up. 11 by 80 binoculars, they're actually back with me now too. The first for the loan program, the knee light switch or ETXLS, even just got checked out last week. And well, the 4SE is still checked out due this month.
Is it?
Yep.
Okay.
And that's,
I didn't put checked out. I had
Yeah.
available now, but
well, anyway, it should be back this month though, so. Or June, I should say. See what else. That's about it. Not too much change this month, so. That's it for the scope load report.
Thank you. Rule time. There's 2 of them. Who wants to go first? I'll pull up the website and drive here.
who here uses Astrospheric? Me. Or knows what it is?
I
do.
I don't know what it is.
So it is both a website and a convenient phone app that you can get.
the dark sky clock, except it's got,
So like clear dark sky, or some of the, other weather forecasting things. This one is just a little more. Well,
It looks cloudy.
a little more polished generally.
It takes a little bit to.
Refresh rate looks pretty poor.
can you hear me in Zoom land?
I can hear you. Can you hear me?
Yes, sir. Thank you.
we can hear.
Your refresh rate is, it appears to me it's pretty slow.
Oh, we stopped.
Could be my connection.
The screens all went back into the ceiling at 9 o'clock, so
Oh,
I had to reset the room again.
oh, well.
So Astrospheric, right? You've got your weather map up here. You've got your day and time across here. So you've also got the rise and set times for the sun and the moon. You have wind direction, temperatures. Then it explains what each one of these is. So cloud cover, transparency, and seeing. So if I click here,
You're gonna
see
have
the
to be
clouds
extra slow
change.
For the refresh, John.
Okay. 3, 2,
It
1.
looks similar, but
Yeah, I'm not transmitting video on purpose because it's looking a little blocky more than it actually is.
So I've got,
Saturday at 9.
can you share? Yeah, you can share. Mike's gonna share his phone.
Ooh, let's call.
We're waiting for your calls. Please stand by. Your call is very important to us.
Caller number 10, you're on the air.
Okay, so here's Mike's phone.
Got enough apps?
Okay. Is that easier to see?
Yes.
Okay. I can't really highlight stuff, but as you click, yeah, so you got the weather map up front. There are different little types of weather. So we're just on the basic cloud cover, but there's some other more fancy versions of overlays that you can put on the radar if you have the paid version, which is like $3 a month or $24 a year. However, if you are an astronomy club, you can register your group with what they call subspace, kind of like MySpace, but for astronomy clubs. Anyways, we set up OAS as a group. So if you're in the app or if you're on the website, in the top right corner, there is a little S. And if you click that and click join group, it gives you the option of entering a subspace code, which is in the chat. And it's a really long alphanumeric string of characters. Anyways, if you go into Discord, it has been posted on there with instructions on how to follow along. If you need help or want additional assistance, you can email me or probably John or anybody on the.
Don't move your phone around so much, you're flipping the screen.
I apologize. And we'll try and walk you through it. But anyways, once we get 20 people signed up, which we are currently at 12, so we need 8 more people to sign up. If we have 20 active users that are in the group, then we actually get all of the pro features of the Astrospheric app for free for all the members. So you can start doing those more advanced radar overlays, some of the more detailed cloud cover predictions. And you can activate the ISS alarm. Whatever that's supposed to be. For outreach and handy.
I got the pro.
You have to upgrade to the pro?
I'm not sure what the, I think once it is, the pro, you already have all the features of the pro, it's just blocked off because you don't have the access code. Or it's not, on this, on their side of things, it's just not switched on for you.
Right.
And so once we have this, then all the people that are signed up. The only account information you need to give them is an email. There's no, you don't like log in or anything, you just sign up with your email. They send you an email, you confirm the code, and then you're logged in. But once you have that account, then you can enter the.
We also have to make a change on the website.
And well, yeah, one of the conditions is that this is the only weather prediction cloud forecasting applet that we have on our website, so we'll be, sorry again. We'll be switching over the website's cloud forecasts to the Astrospheric
Widget.
widget.
Where on the Discord server can you get the app? Do you
It's
remember?
under weather.
The app you just get on. Just
Your-
search for it.
Yeah, whatever app
Right, I'm
store
talking about the
for
code.
your phone, but
The
the
actual
code is in the weather. tab,
It's in the
Weather- weather channel.
weather town. Okay.
Not
I
to
have
be confused with the weather channel, but the OAS Discord weather channel,
Weather.
hashtag weather.
I will add that.
I may need.
Are you gonna open it up on your phone while you have it there? Oh, well, we can kick you out, that's fine. You don't want to show you any, have you show anything sensitive on your phone. Stop, thank you. All right. And get back to my. What am I doing? Louis, you had a tool time. That's right. Sorry. Thank you for letting me look at you and reminding myself. This world.
First off, this makes me feel like,
Gene Rayburn?
no, Drew Carey.
Pull it back.
So, come on down. You have won the showcase. No, oh, sorry.
Little hot.
Little hot, okay. Well, if you know me and some of my astronomical interests, you're probably thinking, oh, he's gonna talk about sunspots again and how in June, how in May, the sunspot monthly average went back up to 137.9 and all, but no, that's not what I wanted to talk about tonight. I do want to talk about the sun, though. Next April, I think the sun's gonna do something well, no, it's not gonna do something interesting. The moon's gonna do something interesting in front of the sun. We have a total solar eclipse happening then. How many have made arrangements to be in the path of totality? All right, so there's a few people that aren't interested in what I'm going to mention tonight, but the Platte Valley Astronomical Observers, which is an astronomy group in central Nebraska around Grand Island and all, have made arrangements to be in the path of totality down in Texas at Andes on the River. One of their club members had jumped in and reserved one of the rooms at Andes. And unfortunately, he passed away and his wife is not an astronomer. So the Platte Valley Astronomical Observers have a room for 3 nights down at Andes that's available. They haven't turned the reservation back in yet. But if you're interested in joining them, get in contact with Mark Erweller, who's the president of the PVAO. And to get his email, just get in contact with me or Bill Bond or John Johnson. Or even Mike Motorson. Yeah, and we'll get that to you. So if you're interested in that, see me and I'll give you the information. So you've won the showcase.
Thank you. Thank you. I keep tripping people with my bag.
$1 a month.
Now, if you were here earlier before the meeting, I had made the joke about Match Game and Gene Rayburn. So
No, you look more like Drew.
I look more like Drew because of my glasses.
No, because of the mic.
Oh, well, Gene Rayburn actually worked to have that microphone designed. I believe it is the E53. I don't know why I know that. But I do. I think we're gonna go straight into the business meeting now. Okay. Minutes. I can bring you the microphone. Look at that.
Oh, my goodness. That is indeed working. Oh, my goodness, what a gadget.
It's a ruler and a paper clip.
Very sophisticated. Hey, works. Okay, May meeting was held on Friday, May 5th at 7:30 PM. Hybrid meeting here and on Zoom. We had 24 members present here, about 10 on Zoom, 2 guests. At least 12 people used AstroPark. There were no awards. Somali gave us a quick review of observing events with the moon occulting Jupiter probably being the highlight of the month, and then the moon, Mars, and the Beehive cluster were close together that month as well. Outreach, we had astronomy at the park scheduled for Tuesday, May 9th at Lake Zarinsky. NSP Star Party at Maloney State Park on Friday, May 26th. The Arts and Garden Star Party on Saturday, May 27th. Miscellaneous events, Club Star Party and Barbecue be held at Astro Park on Saturday, May 20th. Mentioned that Mizral is being held.
Oops. That's all right. It's 8th, 9th, and 10th.
Oh, it's 8th, 9th, and 10th. Yeah, that's a mistake then. Okay, so we need to correct that. And it's, what's the location? Is it?
It's
St.
in
Louis?
Tulsa,
It's in Tulsa, Oklahoma.
Jenks High
Okay,
School.
and so that's coming up, and of course, NSP is coming up July 16th to 22nd. Telescope loan program, Stafford reported, the 11x8 binoculars and refractors were available. The 8-inch SCT was checked out. The 4-inch SCT was checked out. 2 of the Dobbs were available. The light bridge was out for repairs, as was the 13-inch Dobb. The Coronado PST was checked out. Tool time, Tom Wilson showed us some photos of the recent spectacular Aurora display, which he took at his house. We had a program about comet narrowband photometry by Allison Blair, who has worked with the Lowell Observatory for many years. And she talked about how the observations are revealing information about comet formation and the conditions of the early solar system. For business meeting. Significant part, the Astro Park survey had been completed, but at that time we did not yet have the survey results that had yet to be filed with the county. We started talking about planning the fence installation. Mike Morrison told us his employers agreed to donate metal roofing for the shed that we need to repair down at Astro Park. We needed to get information about when the lighthouse was last serviced. It looked in good shape, but there wasn't anything under the maintenance log since August. Mizral Organizing Committee's meeting on 3rd Saturday of the month at the Brain Exchange. We were warned to watch out for some scams because Mike Gallagher received a scam email from somebody who was posing as John Larson, requesting that money be sent to him electronically. So somebody's lifted names and email addresses from the OAS website, so yeah, don't send any
Don't send my
transfers
John.
through, no Zelle transfers or anything. No online transfers because you don't know for sure.
And they did not misspell my name.
No, they got it right.
Mm.
We discussed at the previous board meeting a 3-year property improvement plan for Astro Park. Roughly year 1, which is this year, the property survey, installation of fence, repair of that shed, and fixing the drainage problem at the culvert. Year 2, next year, fix the piers, install a newer, larger concrete pad for large telescopes or multiple users. Put some safety rails around the edges of the concrete pads and repair the wooden steps.
That would be nice.
Then year number 3, 2025, re-rock the road and improve the parking area. And it was agreed that a separate budget would be drawn up each year to cover each of those planned projects. Mizral, John will be buying a domain name for Mizral 2024 because we need to be able to bring that information to Mizral 2023. Name will probably be Mizral2024.org. Krista Teston suggested making some save the date cards that could be taken to Mizral 2023 as well. It was agreed that OAS probably does not need to take out a $750 loan from the Astronomical League to make the arrangements, and it simplifies our planning somewhat if we don't. John suggested selling some T-shirts to help raise money for the convention. We received a donation from Jay and Laura Gibbs of a 6-inch Orion Astrograph AVX mount and a tripod bag and cases for the various components of the telescope. And then a motion was made to close the business meeting by Bill Bond and seconded by Tom Wilson.
Corrections.
We had a few. But they were just the date of. Correct,
Yeah,
Misrule date and location.
here's Misrule.
yeah,
Date, location.
oops, I'm going too far up. Oh. There it is, okay, so we'll amend miserable. Dates
And location.
and location. Jenks, Oklahoma. 8th, 9th, and 10th. Right. I think that's correct, 8th, 9th, and 10th,
I think it's maybe 7th, 8th, and 9th.
7th, 8th, and 9th.
Just going off my head.
Oh,
Wednesday through.
9th, 10th, 11th. Okay, I can see it right there. This Friday is the 9th. So 9th. I have been working on 2024, so some of these dates next year are very similar. Motion to accept the minutes as amended. Steve, and then seconded by Bill. The motion has been made and seconded to accept the minutes as amended. All those in favor say aye.
Aye.
Opposed? Thank you. Need to. Now we need to do treasurer's report. Oh, there you are. You can walk up if you want, or you can meet me halfway. Watch them steps. I hate, these are getting a few people.
Yeah.
I grab it.
This room was designed for spry young people.
So, I was gone most of it.
Yeah, there you go.
All the way.
Yep.
Income was 249.83 in dues, all dues. Expenditures, nothing. And the balance in the treasury at the end of the month was $16,061.89. And in May, there were 3 new members and 3 members that left. And we received some ballots, a balloting thing to do.
Oh, thank you for reminding me about that. Yes. Yeah, thank you. I have an electronic version. I should probably pull that up. That will be in new business. Vice President's report.
I don't have anything new to report. I've been out of town most of last month as well, so I should be heading out to Astro Park later on this month, and I will look things over then. I also still need to follow up on the lighthouse.
Okay. Cool. Old business, land survey report, that's submitted to the county and we got our copy. Right then we'll next time. We're still meeting on Miserable. We had a very productive meeting. In May, we kind of buttoned some things down as well. And we're going to start to pursue our venue here in the next week or so. Would that be a correct statement? Because of the way that the state park works, we have to do that. You can't do that more than a year out. Because of the way they do dates. So The domain has been purchased. And there's actually a website there. It's very basic at the moment. I need to do some work. When we were down at Astro Park, we put some reflector poles in to try to delineate areas. But I don't think the person mowing has mowed to those poles. So maybe we can try to. Mike, do you have the contact information for the mower, or Steve,
Sure.
do you? Okay,
I do.
maybe we can get them to Steve and we can see if we can just double check that he's, because he contacted you and asked like, am I still mowing? It's like, yes. But it wasn't mowed when we were out there for the party.
Tick City.
Yes, so we had, what was the count? 8 ticks for the party. The 8th was when you got home. Oh, that's 9. That's 9. I had at least 3 on me.
I had a couple of spots I think were bites,
Ooh. Well,
but I didn't see ticks for them.
I've been researching some options.
Sprays.
Yeah, so you can put triazicide like in a spreader and go around. And then you can use like the spray version to spray the brush around the edges to try to reduce the ticks. I mean, the deer bring them in,
What about the tree?
which, oh, they seem to be falling out of the tree.
Dropping out of the tree.
They've dropped out of that tree for years.
Yes,
Oh, have they?
the tree did get a little bit trimmed.
I doubt it, you know. I actually know about ticks and things.
Well, one fell
It was in my
right
hair.
on me when we were under the tree.
It was in my hair, so.
Well,
That's common.
I don't know.
if,
You gotta
if
get
you're
on
in
the
the
low and walk up.
Yes, that's true.
I've dealt with them all my life, and is when you're outside of the city, you're in a rural area, there's gonna be ticks. And you can spray, you can do things for temporary relief, but you're gonna have ticks, and once the weather gets super hot, they tend to reduce. There's less of them around than there are in the spring, but that's just natural, but you're gonna have ticks, so you gotta deal with them, so you know, DEET's been around since World War II, so, you know, yeah, you stink, but put DEET on.
So carpet bombing,
I'd rather treat yourself.
you know, we were treating ourselves, yes.
Treat your clothing with permethrin.
Yeah, that would be the best stuff.
Check yourself for ticks when you're home. They take a long time to bite.
Exactly, exactly. You gotta deal with it.
Yeah.
You have plenty of time to find them.
Yep.
You're making me itch.
I think we should have, I think we should have a flock of guinea fowl down there. They eat
No
ticks.
disagreements, any of that.
Oh, we did submit a grant
We did a grant. It is-
this past week.
been Submitted,
A lot of work in that grant.
find out.
We did a lot of crossing the i's and dotting the t's for that. Oh, wait a minute, that's the other way around. So coming right up. Okay. Astronomical League ballot. So if you could bear with me for a moment.
Somebody entertain while I pull this up. I forgot to get ready.
That takes all the fun.
This is for AL officers.
Yeah.
How many candidates?
There's one candidate.
I vote for that guy.
So do I.
Oh, okay, now I gotta find where it was.
What position?
So we know. Whoever isn't here.
Secretary?
Yes.
Terry Manning.
It was Terry Mann.
Yeah, I vote for Terry.
Okay.
So do I.
I mean. I
Make a motion that we vote for Terry.
Second.
Seconded.
If he's the only one,
She.
unless there's somebody here. who wants to
Accept the slate of ballots as presented.
Okay.
Slate of candidates.
What is Terry running for?
His current position as secretary
Ms. Terry Mann,
for,
nominee for Astronomical League Secretary 2023-2024.
Great.
Currently. Sounds good.
Gary used to be president of the league.
I'd say she's qualified.
All right. Who was the first? Bill?
Bill.
Found one of my certificates.
Page 10, if you want to read.
Who seconded?
Nina.
Steve? A motion has been made and seconded to cast the ballot vote for Ms. Terry Mann for Astronomical League Secretary for the years 2023 and 2024. All those in favor say aye. As opposed?
Aye.
Good, thank you. Oh, and then the other fun one. Yeah, this was not the, this was the other one. The 2023 ballot for officers,
On the back of the paper there.
the bylaws ballot.
Oh, my God.
Now,
Israel or for AL?
for the league. It's not for Miswell. The league has redone their bylaws as well. I know that we worked on the Miswell ones, but this is the Astronomical League.
Have you reviewed them?
I have not reviewed them yet. It is due July 1st. So I can have time to review it. I can post it on Discord. And then we can revisit this.
yeah, I like that.
You're shaking your head. Does that mean no, we'll revisit it? Certain countries, that means yes.
I think I would delegate it to you if you think they're reasonable.
Okay,
I agree.
Make a motion.
So moved.
I move that John reviews the bylaws and approves.
So
it.
you have suggested
Nobody wants to
bylaw
read-
changes?
hear all of them.
I have not worked on these bylaws. I worked on the Misrule bylaws.
It's a very short, two things, you know.
Yeah, there's only a couple of items on this. It's essentially contracts and convention scheduling.
Those sound reasonable.
Vote for him.
But
Let's vote for him.
let's vote for them.
Then you need to withdraw your motion.
I withdraw my motion. What was your motion?
She's not sure. We're not sure.
Thank you.
I'll make a
They
motion.
didn't really, they just said, I second a motion. And Bill said, I make a motion. They didn't say what the motion.
So moved.
Oh, I said
Yes.
somebody.
So I have to withdraw it.
I'll make a motion that we vote in the affirmative for the changes to the bylaws.
This might affect OAS running Misrule next year in terms of contracts and convention scheduling, but this is mostly for the national level stuff.
They have the same thing though. It
They did.
increases the amount that you could make a
Yes.
contract for. And who you have to get permission from.
Yeah,
They've had it in the same type of thing, only smaller.
so you can read it just as plain as me. In other words, the amounts went from 350 or 300 to 500 up to 1,000 to 2,000, looks like. For single contracts.
To have a contractor work and provide
Things
services.
are costing more, so that
Yes.
makes sense.
So
Good thing.
authorized persons, league officers, regional chairs, national convention chairs, other persons who are authorized by the president in writing or by electronic means for specific purposes. They persons, however, may not enter single contracts in any amounts exceeding 1,000 or multiple contracts exceeding 2,000 in the aggregate. So all those in favor of approving amended Article 10 in Section 5,
You need a second.
a second.
I'll second.
Right, your motion to,
Okay, thank you.
whatever you're gonna say.
Bill.
That's the first one. I know this is paperwork and I
Approve it all.
Second.
understand. Okay, the other one was,
What, no, Bill made a motion to approve all of that.
hey,
You did.
Yeah. The whole thing, and Mike seconded it,
okay,
so all you have to do is.
Call for the
If
vote.
you give us the Cliff Notes version, we'll understand what we're voting on.
That's less.
We're voting on a bunch of dumpy or dokey reference. What's the second?
they just said the convention's held every year in a time and place designated by a majority vote of the council. The reason they changed it is one club made the valid suggestion that we need more transparency in the processing of selecting convention hosts. Conventions may be canceled for reasons of pandemic or other exigent circumstances.
We need that.
So
Motion has been made and seconded.
the motion has been made and seconded to approve both amendments to the bylaws for the Astronomical League. All those in favor say aye. Any opposed? Thank you. And you can see I put my hash marks. Notarized, that's correct. And, oh, I didn't realize you weren't looking at my screen this entire time.
We've been looking at Rob.
Nice. Well. Rob is charismatic.
Robin from.
Did he just pull a face? All right,
Actually, John, we've got you on our Zoom.
just me?
Yeah, that central camera looking at you. That's
Oh.
what we've been looking at.
Okay,
Just the room has.
how about now?
New business.
Okay, here's another new business item that's just fresh tonight. Reestablish building and pad numbers at Astro Park, which will make it easier to identify for maintenance concerns. I believe in the past, the buildings used to have numbers on them. They currently don't have numbers, so I don't know which one's which.
I know building 6 has a number, but it's very faded.
Yeah, so we know there's building 6, but there's not 6 buildings.
Somewhere there is a diagram that indicates the numbers on the buildings,
Really?
but I didn't ever know if the numbers were on the buildings.
Oh. So
And as
those things said
treasurer,
diagram.
some of the information that I held, I don't know if it's still
It might
with
be,
the treasurer or not.
I might have that. I've seen that before.
Attached.
Yeah.
I probably have it.
It's just a diagram and there were numbers on the diagram.
A map of the park.
okay,
Now, however we want to change them, it's just a new diagram and new numbers. If you can keep them the same or renumber them or whatever you like.
well, I'm thinking for the purposes of the. I know we don't really technically have
Oh, they go to 5.
Yeah.
signed leases, right?
I never saw a lease. I was just called and told,
Mhm.
my friend and I rent that building. What do you mean? None of them are rented? I went, oh, I didn't know that.
Gonna be flying low.
Yes,
They
part of
sent
our,
me money.
part of the cleanup procedure, yes,
Yeah. And I didn't pursue it any further than that.
okay,
I took people at their word.
so. Good idea,
Yeah, good idea.
Sure.
Very good.
I
Why not?
okay,
I move that we reestablish numbers and do it in some fashion.
Mike M moves, so makes the motion.
3 or 4 inch stencils and some paint and you've got it made.
Oh, I got some ideas, maybe get glow in the dark paint,
Fancy possibility.
is there a second?
I'll second.
the glow in the dark.
Diana seconds,
Go to Ace Hardware and get the address number.
it says glow in the dark,
I think it's be fun.
Just use a piece of paper.
All those in favor of the a motion has been made and seconded to reestablish building numbers and pad numbers at Astro Park. All those in favor say aye. Opposed? Okay, we know we gotta talk about it.
No,
He said no.
it's voting no.
Motion carries.
Motion carries.
Okay,
Say somebody doesn't want to blow in the numbers.
well, usually when there's a no, that means-
Contrarian.
Oh, somebody's taken up
Ed
Ed's
Sikorsky
stance,
goes
where
with
he
Ed Sikorsky.
always said no to everything.
Oh, I see.
Ed,
Ed, was it Ed?
Ed Sikorsky used to say.
Yeah,
no to
he used to always say no.
That's something.
Hey, guess what? NSP's coming up next month. Isn't
6
it
weeks.
Six weeks.
Yeah.
And registration ends June 15th.
No, that's for the discount.
That's the discounted.
Yeah, the discount. You can still, we'll still take your money, after this, after the.
Even on the field, you'll take the money.
Yes.
just take more.
You can walk in as well.
So
How many got signed up?
A little over 130 right now.
that's pretty good. And you do need a park pass to go.
Right.
And you can get that through your registration,
Right.
or you can get it at any place in town that sells the park pass. Or you can order them through the state's new procedure.
That's an extra $1.
Yeah, it costs $extra. You can go to Walmart and get it at the fish counter.
Yep.
Where you buy your fishing licenses.
You
can get
it at the park too.
Yeah.
You can get it at the park, at the trading post. But if like going to Mahoney State Park for outreach, I make sure I got my pass on the car.
There's a Game and Parks office on 84th.
Yes, there is. Yeah,
and
84th and
G or.
Yeah, just about.
Oh, there is a Game and Parks office. Okay, I did not know that.
Yeah, and you can
All- yeah,
just go in
just-
and buy it there.
Huh.
Just north of I-80.
And if you're like me,
North of the McDonald's.
if you
Used to be Shopko next door.
if your windshield got broken. And you didn't have a copy of your old pass, you couldn't get credit to get a replacement pass, so.
Yeah, buy a new.
Maybe take a picture of your pass on your windshield, just in case.
I'm not saying this is me, it's not coming from me, but when you put that sticker on, do it with two-sided tape, you can take it off anymore. I'm not saying this though, that I did that, but
I
that
don't
way
know
you
if that
could
was
pull it
allowed.
off your broken window and stuck it back on.
A guy could do that if a guy
You're not allowed
wants.
to do that, so don't do that.
Well, remember, you're being recorded.
Wasn't he that said that?
Who are you?
Mike. Thanks a lot, Bill. Well, there's 4 mics, they don't know who it is.
Jack would
I'm
never say.
saying-
I don't know who that Jack guy is, but. Jim. Oh, wow. Yeah, it's just old fable.
Yeah.
Because the spring barbecue went over so well. I put another one on the schedule for September 16th at Astro Park.
We're 16.
It's a Saturday.
Are the ticks invited too?
Well, they're residents.
Oh, yeah.
You're inviting us.
So I did enjoy burning the few that I saw.
They were good. They were good.
They were not in the burgers, though.
You roast a few ticks in there too.
No, there was one crawling on the cooler, so I hit it with the lighter. Yeah.
I mean, it's just more protein.
Extra crunchy.
Moving along,
Crunchy.
next meeting is July 7th here at UNO. So after the July 4th shenanigans. I don't know what Memorial Park has planned. Or what was being planned for Memorial Park
I think it's later in the month.
later in the month.
Yeah, they're.
I
Sometimes they do
think
it
I heard
early,
that too.
late June or around the 4th, but I think I looked it up.
It's probably the weekend before that Saturday before the 4th,
It
because
seemed like it was gonna be at the end of July.
the 1st is a Saturday.
Annual concert is June 30th.
June 30th,
Yeah.
okay, so that Friday is.
Yeah.
Looks like we won't have to worry about it. Hooray. Any other discussion topics? Anything from the Zoom folks? Crickets?
Motion to adjourn.
Second.
You two are pretty quick on the draw tonight.
Bill and Steve showed us up to do.
Bill B,
No discussion, no discussion.
Steve C. A motion has been made and seconded to adjourn the business meeting. All those in favor say aye.
Aye.
Thank you. All opposed? Thank you.
Are you going out afterwards?
Yep, sure.
Who wants to go to Backlot Tap House over in Garden?
We're gonna put the microphone up.
Tap House. There's no party going on there. 12 people here heard me.
Did you call ahead for a table?
Can you do that, though?
You can, yeah.
So they just.